The certification tests really ask you to take a broad overview of the platform and understand how the pieces and the capabilities provided on the platform can be used to fit together in order to deliver a solution for a customer.
Certification proves that an engineer not only has that real-world experience, but also has the technical knowledge to be able to be certified and to operate at the level that is required.
What certification offers that experience doesn't is peace of mind. I'm not only talking about self-confidence, but also for our customers. Having us certified working on their projects really gives them peace of mind that they're working with a partner who really knows what they're doing.
Alright, so in this video, I'm going to show you how to use Kumospace. So the first thing you're going to want to do is go to this link right here, kumospace.com/cloudcoach. It's going to take you to a page that looks just like this, and you're going to want to click one of these three sign-in buttons. I'm going to use sign in with Google. So it'll probably prompt you for what account you want to use, and for me, it just selected it by itself. It'll then, once you're here, it'll probably prompt you and say, hey, can I have camera access? Can I have microphone access? You're going to want to just click allow, and you can select what all you want here. You can also change your name for your little icon that shows up inside each room. So then you're going to want to click the join button. Then you're going to want to click on one of these three lobbies. You can see how many people are in each lobby, so you're probably going to want to find a lobby that has someone else. There's no one here right now because the event isn't up yet. So you're going to want to click on this lobby, and then once you join, you'll be greeted with a little entrance that looks just like this. You can zoom out, and if you pull up the map here, you can see the whole thing, and you can just click anywhere and it will take you there. If you click over to here, you'll be able to see this YouTube video, and everyone will see the same YouTube video playing at the same time. So that's super neat. Another thing is that if you see this little circle that's here, anyone within this circle will be able to hear you and see you if you have your camera on. And you'll be able to see or hear anyone within this circle. So that's super cool, and it allows you to have a little bit of privacy while also having these kind of opener conversations where people can join in. And that's super neat. There's also a bunch of different stuff you can interact with, like this, and it'll show little icons here. You can also give these little react symbols, and that's all the main functions of Kumospace.
Hey everyone, thank you for joining us for our presentation on 30 Days of Cloud. My name is Chetan from the University of Ottawa, and later I'm going to introduce Rahul, who's from the University of California, Santa Cruz. And here's the presentation. So what's 30 Days of Cloud? 30 Days of Cloud is a GDSC community event introduced by leads and core teams of 16 different universities all across North America, here to give you knowledge on the Google Cloud Platform. So I'll be going over some important links that you're going to be needing throughout this presentation. The first one is the cloudcoach.dev website, which is pretty much like our platform to show the live stream where you can see the chat and this YouTube stream going on right now. If you go to About Us, you can see what this event's about, our wonderful developers who worked on it. And if you go to Home, there's also more information about what 30 Days of Cloud is. But most importantly, you should go and register with your information just so we can keep track of which students from which school earns the badges. And people that earn the most badges actually win cash prizes. So in the leaderboard tab, we show that below. We show which university has the most students with the most badges, and as you can see, Sheridan's at the top. And these are the number of funds that have been unlocked already, the number of participants, And you'll see as more people join in, we're gonna give out more cash prizes for people that sign up. And there's also a button right here to go to Kumo Space, as shown earlier, and there you can go and sign in for Q&A. So the next link I'm going to be going over is for our Quick Labs code, and that will be very important for the lab. The link is should be on the screen right now. So if you go right here, I had the lab started already, but this is how you actually gain access to the 30-day subscription. So what you'll need to do is just press Start Lab to have this running in the background for at least 5 minutes. And you're gonna have to do some sort of CAPTCHA. And you don't need to do anything, just have it running throughout this presentation. I'll at the end of it, I'll tell you when to stop. But when you do end the lab, you should get a subscription for 30 days, as I've gotten. And with that, you can do as many labs as you want within the 30 days. You have the platform to yourself. So with that, I'll be going over to the next link, which is the lab that we're going to be working on today after this presentation. So how do you go to that? It's going to be go.quicklabs.com/HeyStudent. And once you go there, there's going to be all the modules, all the topics that we're going to be covering today, or topics that we're going to be covering over the entire 30 days. But today we're just going to be covering a module in this section right here. So you're going to click Enroll. And from here, you're going to have to just cancel this because you already have the monthly subscription. But you're going to click on the number 4 here. And as you can see, there's a bunch of videos that you can watch in your own time. There's a bunch of documents, a bunch of labs that you can complete. And once you complete these, that's when you get the badges. And if you have badges, you have a chance of winning the cash prizes that I mentioned earlier. So as I keep going down here, you'll notice the one we're doing today, which will be done by Rahul. But yeah, that's how we get there. So this won't be accessible just yet, but once it the Quick Labs code, the timer runs out, we'll be going to it. So, okay, next slide. All right, so why would these be important? If you're looking for a career as a data engineer, a data analyst, or a data scientist, these the data and machine learning module is going to be the most important one for you. Or if you're just going to something related to cloud, like cloud DevOps, cloud engineer, or cloud network engineer, any of these modules like infrastructure, network security, and multi-hybrid cloud infrastructure will be important for you. So these are some of the topics that, all the topics that are going to be on the Quick Labs platform that you can learn, which we kind of went over earlier. And you can see like all the topics that you can learn and do the labs with. So the one we're going to be doing today is this one, but as you saw earlier, you actually have access to all of these. So in your own time, if you just want to go ahead and do more than one lab and earn like 10 badges, that's completely up to you. Here are the badges that you can learn with these modules. So Google Cloud Foundational Infrastructure, Foundational ML AI, just as some basic badges. And even after you're done these, there's even more badges that you can learn just throughout from the Google Cloud Platform, Quick Labs. So yeah, the world is yours for 30 days. You have access to this platform completely free to earn as many badges as you want. And we highly encourage you to do so, not just so you can show it in your resume or have it on your LinkedIn, just also so you can win the cash prizes that we're offering. So how do you earn a skill badge? You earn the skill badge by doing the modules, and you'll need to make your profile public after you do so too, which you can follow the instructions here, which this link will also be in this register page that I showed earlier, but they're in the cloudcoach.dev. But yeah, when you go there, there'll be a place to make your profile public, and you can link that profile into your LinkedIn, your resume, or whatever you want, so people know that you're competent in these technologies. So with that, I'm done my part of the presentation. If you have any questions, you can drop them in the chat right now. But I'm going to be moving this presentation over to Rahul, who's going to go over the lab that we're doing today.
Can you hear me? Okay.
Yep, you're all good.
Okay, so I'm going to be doing the lab today. So if you go to the Hey Student link and you go to number 4, Data, ML, and AI in Google Cloud, just make sure you're signed in for this to work. And if you're not signed in, just take some time to sign in right now, or the links don't become active. And you can scroll down to let machines do the work. And today we're going to be doing the AI Platform Quickstart Lab. So I have the lab open right here, and this lab gives an introduction to TensorFlow and also how to use the Google Cloud AI platform. And specifically in this lab, we'll be training a data set or training a model to predict income based on the United States Census data income. And so to start the lab, you need to click the green Start Lab button. And just keep in mind that clicking this button will allocate like Google Cloud resources, and these resources are paid resources, and they're available for a limited number of time. So once you click Start Lab, you'll have 1 hour to finish the lab. That being said, I'm going to click on the Start Lab. And it'll cost 1 credit. So I'm just going to launch it with this 1 credit. And so the first thing to do is to sign in with the Google console. You can click sign in, and I'm just going to, if you get a bunch of accounts, hit use another account, and you can use these credentials that the Quick Lab provides you. So student, and then and you can accept the Google Cloud Platform Terms of Services. And it's better to open it in an Incognito window, because I think what happens is it gets mixed up with the other accounts. So I'm just going to be doing this in an Incognito window. So here's what the Google Cloud Platform looks like. And here you can also agree to the terms of service and continue. And once you have your project set up and you've signed in, you can launch the AI platform. So to get there, you click on the navigation menu and navigate to AI platforms. So here's the navigation menu, and artificial intelligence. Artificial intelligence AI platform, and we're going to notebooks. Also, let me know if you guys need me to slow down or anything like that. So question,
Rahul.
Yeah, sure.
Is this notebook? I think it's similar to Jupyter Notebooks, correct?
Yeah, so this notebook is a Jupyter notebook that we're going to be creating on the in our Google Cloud project.
Awesome. So if you have familiarity, you can always integrate that into this.
So to create the new notebook, you hit new notebook, and then we want to create a TensorPrise or TensorFlow Enterprise 2.x with the latest version without GPUs. So we go over to TensorFlow Enterprise, and it's the one without GPUs. And there are some more things that we need to customize. So we can set the instance name for if we want, but I'm going to just keep it TensorFlow or the default name. And then for region, we're going to select US Central 1. And then we can scroll down to machine configuration. So to get to the machine configuration, you go to the advanced options and you can find machine type, and which needs to be N1 standard 2. And then we can leave the rest of the fields as they are, and we can hit create. So it takes some time, but for the Google Cloud Platform to create the notebook, but once it's done, we'll have a fully functioning Jupyter Notebook in the cloud.
Have you ever used Jupyter Notebooks, or have you ever used Collabs, Rahul?
I have used Collabs. So Jupyter Notebooks are pretty much a way that it's an easy way to run Python code or to visualize data sets or to train models, and it's really useful in ML work and AI work.
Because I noticed, like, when you set this up, you had the option to use Python 3.6, or you had the option to use TensorFlow, right? So I guess all the libraries are pre-installed if you were to select TensorFlow, and if you're doing a TensorFlow project, so you don't have to worry about like setting and calling all those libraries.
Right. Still setting up the proxy to the Jupyter Lab.
It is taking its time.
Yeah, I ran through the lab a little bit earlier. This part took like a couple of minutes, like 3 minutes.
I think it's because it needs to allocate all the resources that it's looking for. And
Mm-hmm.
how big is the data set that we're going to analyze today?
So the data set. So this is kind of the Jupyter Notebook that we're going to be working on today. That once we get the Jupyter Lab set up, and then over here we can find the data sets too.
I think the data set is pretty big. Maybe that's why it had to allocate so much space. And for those who are listening in, do you want to quickly, till this gets up and running, do you want to jump on, open a tab and show what Collab is?
Sure. So Google Collab or Collab.
That's correct. Yeah.
So it's a way of like having small chunks of Python code. We're running it at the same time. And what's cool about Collab, or what I like about Collab, is you can easily visualize the data sets. If you have something like pandas or NumPy, they have, or even like SymPy, it's easy ways to visualize exactly what you're coding.
I think the other interesting thing is you have access to TPUs in this.
Yeah, so it's kind of like having your own, like, you can have a more powerful computer, and which is really useful for like ML or like any AI training, because you have TPUs which can train the data much faster than if you do it locally.
Yeah, for those who are not familiar with it, so your computer's processing power is limited if you're trying to do a lot of machine learning work. Especially like Python takes a lot of memory, if I remember correctly. So and when you try to do it in the cloud, sometimes you're going to run into issues as well. So I don't know whether you want to show them. I actually know. So it's done.
Yeah, it's done.
Yeah. So my tip is, one of these days when you get time, go play around with virtual machines, and you'll see the TPU option. Just click it and see the prices. I think monthly you have to pay like $1,000 to use a TPU. So, and you get access to it for free to experiment on Collab.
You can just set the hardware accelerator over here to TPU, and it's pretty much a free TPU that you can use to do any ML training that you need. But anyway, so now that the Jupyter Lab has been, like, the resources have been allocated, I'm going to be opening the Jupyter Lab, and we can continue with the lab. So we see this new window that just popped up, and so the first thing that we need to do is we need to open an instance of the terminal, and we need to run this command which clones the data set to our local or to the cloud computer. You can see that it's creating this new directory, training data analyst, that was last modified seconds ago, and it's still downloading. So now that that's done, we can go inside this training data analyst folder and see all the files that I downloaded. But right now, mainly we're going to be working the self-paced labs and the AI Platform Quickstart, because this is the lab that we're doing. And this is the Jupyter Notebook that is provided for us. So I think from here, we don't need to go to this lab. We just need to go to the quick lab to check the progress, but we can mainly stick to this this Jupyter Notebook for now. So how it works is you need to run each, I guess, block or each cell, and then that snippet of code runs. So the first thing that we're going to do is import the OS module that Python has. It's a built-in module that gives you access to functions on the system, like creating files or creating directories. So here you're invoking the bash shell, and you're making a directory called data and you're downloading the sample data from. So you can see this data directory just got created and it finished. And now we're setting some environment variable training data and eval data to where the respective data sets will be. And then here, just to see what we can invoke, we can just see what's in adult data.csv. So this is like the comma separated file of all of what the data from the US Census looks like. So the second thing we're going to do is, now that we have all the data, we want to run a job like locally, and then later we'll be deploying it to the cloud. So we need to create some Python files to first actually train the data and to actually clean up the data. So the first thing that we're going to be doing is what's called pre-processing the data, which is kind of cleaning out what the data and only use what we need and have it in a way that's easy to modify and play with. So this creates a trainer directory, and in this directory this is the file called util.py, which has the methods for cleaning and pre-processing the data. So the second thing that we need to actually train it is a file called models.py, and this is pretty much, it explains what the structure, it defines the input functions and the model architecture, and it kind of defines the structure for the neural network. And the last file that we want to have in our trainer file is the task.py file, which pretty much actually trains on the data that uses the above model.py and util.py to act.
So all the whole breakdown is available, correct?
Yeah, the whole breakdown.
Okay. I mean, any tips, Rahul? You sound like you've been playing around with machine learning for a bit. Let's say you had a problem. Is there a way to decrypt this code and like tweak it, or would you go back to Collab or Kaggle and look at other examples as to how others try to solve a problem?
Oh, I think the main way to solve the problem would be to just go back to Kaggle and just tweak the parameters in the data set, or even like in the model, like when you're creating the model, you can tweak the parameters. Also, something that's really helpful is just reading the docs. Like, I know it's being said a lot, but reading the docs is the easiest way to get started with TensorFlow or any machine learning like library. So
I guess the point I'm trying to make for everybody who's listening in is, don't focus on don't get disheartened by just the fact that we had to copy and paste these things. The purpose of these labs is to show you how to get access and understand what GCP tools that are available. But to understand what you need to solve, there are other tools other resources that you can tap into. Collab is one of them. I think there are examples that you can look at how other people solve problems. And Kaggle is another one as well. So you have even challenges, right, Rahul? Like you have like some big businesses, they pour in like $25,000 to $100,000 of cash prizes for anybody who can solve the problems. They have data sets there. So the point I'm trying to make is, see what they try to do there. And if you want to experiment on the cloud, then you can come and create a GCP instance like this and test it out and see how it goes.
Yeah, and if you're like, I know Kaggle is a really good place to get data, or just to get any data if you ever want to play around with machine learning and you need some data. Just Kaggle is like my go-to place for that. But anyway, so once we have all these Python files, well, we can run a command to actually start the training job locally. And this command is basically saying, telling Google Cloud to start a local training session. and we're going to be using the trainer. The mod, it's basically the folder is in the trainer folder. And we set all the environment variables earlier of where the train file or where the files, the data files would be.
Can you elaborate a little bit as to what local means in this case?
Right. So in this case, local basically means instead of running it on the Google Cloud platform, you're running it on your local machine. So you'd be running it on your MacBook or on your Windows PC using all the resources that you have, as opposed to doing it on a server with much more resources. And I guess what you'd like to do that first, so you could test it and make sure that your model works and it's doing what you want before you go out and deploy it, because buying these resources is expensive and you want to make sure that you're not wasting any money. So I think it's still running. Yeah, so we can see that it just finished running. And we can see the output in this. The output was sent to Kara's export. So here we're getting some testing data for to feed to our neural network, and we can get this from the load data method that was in the util.py file, and we can save the inputs, and we can also save like what the target should be. So here's what the input would look like. So if you pass an age and a work class and education number and marital status, and these things are all like numbers because we pre-processed the data and we cleaned up the data. So we converted like all the like letters or the words and strings to numbers, so it's easier to run neural networks on them.
By the way, Raul, like we didn't have to import pandas or anything like that in the beginning.
Yeah, so we didn't have to import pandas in the beginning because we created when we created the notebook, we used the TensorFlow notebook. So
cool.
yeah, so that's why TensorFlow was already imported, and we didn't have to do anything like that.
So I guess the best use case here is it's better to experiment here and deploy if you're planning to deploy code into the cloud in the future. So there's no point of doing it in your IDE and then deploying it and making sure to make all the calls as a cloud function, for example. You can test it right here and then deploy it from here straight into the cloud. So it's already integrated in there. I think keep in mind I think this is Veritas AI, right? It's a little expensive compared to like Cloud Run or Docker or Kubernetes, but it's less work. So there's that too.
So what we can do is we can write all this prediction input to a JSON file. And we can also see what the JSON file looks like. So this is a file of a potential input that would be passed to our model, and which is containing everything from age, work class, to education, marital status, occupation, relationship, but in this file. So here we can use our training model for we can use a trained model for predictions. So I think if the number is above 0.5, that means the person or this individual or the model is predicting that this individual makes more than $50,000 a year, and when it's less than 0.5, it's predicting the individual makes less than $50,000 a year. So since the model's last layer, so now that we ran the model locally, we can actually deploy this to the cloud. And the first thing we need is our GCP project name. And we can run it with this command, and we can see the project name is this. And over here, we can set our project variable. And you just want to replace it with whatever your project name is. So mine looks like this, so I just replaced it. And then you also want to run this, which sets some environment variables such as the project, the bucket, the region, and so on. So now we're going to be setting up a cloud storage bucket. And this command basically checks is if there's a bucket, then, or if there's no bucket, then create the bucket. And now we're changing the training data and eval data to run on the actual bucket as opposed to the local clouds or local machine. And we're also going to be copying the JSON file that we have to our bucket. So now I'm just going to go back to the lab and check the progress. I'm not sure what's happening.
Are you so I'm incognito or what?
I'm not in Incognito.
I think the system got confused with
Okay. Right. Okay.
So you got to make sure you're like always in incognito.
Right.
And what happens is it might think, oh, you were somebody else, so because you had a different login.
Yeah, I think that's what happened.
And this happens to me every day because I have different GCP instances.
Yeah, I have a lot as well. I have some for work and then some just personal ones.
So either you got to switch the account or you got to make sure you have just one instance running on incognito. And you are going to run into this too.
Okay, there we go. Okay, so that got completed. So now we can go back to the training data. And it's a similar command to what we did earlier to run the files locally, but instead we're going to be running the files on the cloud machine or on the bucket that we just created. you can see that we created a job to run this or to train the model, and right now the status is queued, but and then when it gets finished, the status will be, I think, completed. You may view the status of your job with this command.
Any tips you can share, Rahul, on how to decrypt these instructions or the codes?
Or these ones?
Yeah.
Yeah. So, well,
Do you use any resources? Because here's the thing. I mean, some of us try to reverse engineer. We look at somebody else's work and see how it's done, understanding the problem, understanding where the answer we're looking for is, so we can understand it better. Any resources you can recommend?
I think there's a Google Cloud AI platform. There are docs for this, but I have not seen them. But I can explain what this is doing. But you're setting this is setting the job directory, and then you're setting the runtime version, which was all set earlier. And here we have the job ID that we just created, and then the runtime version was set when we created this notebook, and so was the Python version set. And we're setting the module name, which is the trainer, and we're setting all the train files and the eval files and the steps. So here we can set an environment variable with this job ID that was generated above. And we can go to AI platforms and jobs and see. So it's still running our job. I think if we want to check the progress, the data was uploaded, and so the job has been submitted, but it's not succeeded. So it's still working on it.
Rahul, how many labs, how many badges have you earned over time?
I've done a couple. I've done a couple badges. I think I've done one of the labs.
Obviously, this is not the most exciting kind of way to learn as a group.
Mm-hmm.
It's more self-paced. Would you recommend going through this kind of model to experiment and go through?
No, I definitely say on my own, it's pretty interesting to go through the labs. I've learned a lot about TensorFlow and just about all the Google Cloud products just by looking through the quick labs and seeing everything Google Cloud Platform has to offer. So it's definitely worth going through on your own, and even after the review, just go you can read through the code and see exactly how it works, and you could use it. You could also play with it with your own data sets. That's kind of what I recommend on how to the best way to learn. More is just to experiment with your own data sets and see what works and what doesn't work, and in terms of making the predictions better.
what was I going to say? I don't know whether you know anybody ever told you about this. Every new engineer we bring in who's going to be working on cloud as a support service or somebody who needs to get familiar with GCP, they go through all these labs on their own. And there's a training module around that, and you can find the whole lessons, the breakdown of it on Coursera. And Coursera integrates with Quick Labs the same way that you have it.
Hmm.
So if you ever want to go through the Coursera Google Cloud Engineer role, let's say if you want to become Cloud Engineer at Google, just go through that course, and you don't have to pay for Coursera if you just want to audit the course. And then when you need to go to the labs, obviously you need to have a subscription, but then you can, if you get this 30 days subscription for free, then you're pretty much covered there. So you can watch all the videos there, or you can go through all these fundamentals and work towards that. And I'm not kidding. Once they all get accepted, they need to go through all that and complete it. That's all their training, so it's available for anybody to access. And then the other interesting thing is a lot of these industries are moving from on-prem to cloud, or sometimes switching between different providers. So if that's the career path you want to take, there's a lot of resources available that you can tap into, and it's all available for free in most cases. So.
All right. So now that the job has been done, that means the model was trained on the Google Cloud bucket. We can move on to the next step, and we can check. So I just checked the progress over here for running the single instance trainer in the cloud. And now we can set the model name that we're calling it. So because it's trained on the census data, the model name is census. And this is pretty much creating the model. And the next step deploys our model to the cloud. It's still running.
Rahul, while that settles in, quick question. So you're from UC Santa Cruz, right?
Yeah.
I noticed on your page you guys had a TensorFlow workshop from last year. Were you involved with that, or was that an
Well,
ongoing series? Or no?
last year I was not part of DSC. This is my first year at DSC, actually.
Oh yeah, so there's only one video, and I think it was on the TensorFlow Yeah, if anybody wants to check it out, yeah, you're welcome to go to UC Santa Cruz's GDSC page, and it's linked at the bottom. And we should get this link to every chapter that we're running to the 30 days of cloud sessions.
Sure. Not sure. Okay, there we go. So this just created this just deployed our model, and now we can list it and we can see our and that's pretty much the end of the lab. And if we want to, we can send our predictions that our test.json to the platform or to the model that we just deployed. And we can see the result that we're getting. So yeah, that's the end of this lab.
All right. Thanks everyone for joining. We hope you enjoyed the presentation, and thank you, Rahul, for coming on and doing the lab. This link will be put on our Discord, like the University of Ottawa Discord, but otherwise you'll be able to find the recording on the Think Outside the Channel YouTube channel. I think Madhusha has a link for that, or if you're watching it live, it's the channel that this is on. But other than that, we hope you enjoyed it. Be sure to check out the other events that are coming up later on. But other than that, that's about it. Madhusha, do you have anything else to say?
I think all the videos are going to be listed on cloudcoach.dev.
Okay.
So since this website is built by students, so some of them have midterms, some of them got busy, so we couldn't finish everything we wanted to do. It'll be available there. If you haven't registered, please go register. So that way you can join the competition, and then we can tally some of those badges towards your chapters. And then they can claim some cash prizes and goodies and other things. And the other thing is we also want to encourage the chapter leads who are running the sessions to encourage. You can tag the video that this session that you're doing into your chapter, so it counts for your credit as well. And there's also a mailing list, which I forgot to mention earlier. Let me see if I can find it. Yes, so this is the mailing list. I know it's a little long, 30-days of cloud, Google Groups. Everybody who's registered will be on that. And let's say you get stuck, you couldn't get the cloud, you couldn't get a code. Just join the group, and then you can ping the group and somebody will respond. So yes, some of those codes that we shared might expire in 30 days, but we're going to continue this going forward, so you still have access to it. Like I said, if you decide to go watch Coursera courses, now you have a way of continuing to learn this as you go through, right? So, and it's self-paced. You can do it on your own at any time. If you know anybody who who should join, encourage them to join as well at their own pace. And with this link that I'm sharing right now and running that lab for 5 minutes, you get access to everything for free for 30 days, no matter what. So that's about it. This is week 3. We just wrapped up. And we have 1 more week to go. 4 more chapters are going to jump in. We do have a few guest speakers coming next week. If you are interested, also join our LinkedIn page, Double Student Clubs, because we have another event planned for tomorrow afternoon where we're going to go through a GitHub workshop, training and showing how to properly create a public profile on your GitHub, because LinkedIn everybody's focused on as to when it comes to job searches, everybody focuses on your resume and your LinkedIn, but not many developers focus on optimizing and making their GitHub profile pretty for recruiters, even like hiring managers. So tomorrow's workshop is going to be all about that. We're going to be doing some live tweaking on 2 candidates. So it'll be a great workshop to be part as well. That's all I have from my side. Back to you, Chetan. If there's nothing more, I'm just going to play a quick rollout video, and then we are good to wrap up.
Yep, I'm all good. I just want to say thanks to you and Rahul for helping out.
Awesome. Thanks, everybody.
Bye-bye.
Bye.
Thank you. Bye.
The certification tests really ask you to take a broad overview of the platform and understand how the pieces and the capabilities provided on the platform can be used to fit together in order to deliver a solution for a customer.
Certification proves that an engineer not only has that real-world experience, but also has the technical knowledge to be able to be certified and to operate at the level that is required.
What certification offers that experience doesn't is peace of mind. I'm not only talking about self-confidence, but also for our customers. Having us certified working on their projects really gives them peace of mind that they're working with a partner who really knows what they're doing.